All right, ladies and gentlemen, good to be back with you again on our wonderful little video time, chat time, or me talking, you listening and paying attention time. This particular video is going to be going over the 9 problems that I gave you in sections 8.3 and 8.4. One thing I'm going to tell you is you all have done a great job of listening to me and doing your conditions correctly. So I'm not going to actually be doing the conditions for these problems, but there are some things that you are still struggling with, so I need to make sure that we actually go through these all together. First off, number 1, the local restaurant problem. This is the first problem in section 8.3. There's a couple things that I noticed here. I'll read the problem out loud. It says a local restaurant claims its dinners for a family of 4 average under $50. Okay. You test this by surveying 35 random families as they leave. Your mean is 5325. Use alpha equals 0.01 given that the population standard deviation is 715. Okay, this was a little bit tricky because I gave this to you in section 8.3, which was the t-table, but I wanted to see how many of you picked up on the fact that, wait a minute, he's giving us the population standard deviation, so we should be doing a z-score. And the answer to that is, well, I mean, there's only 5 of you, and one of you hasn't done any of this. So the answer to that is not very many of you. Okay, so let's talk about this. First off, we have HO and HI. A lot of you have problems with HO and HI here. It says the restaurant claims its dinners for a family of 4 average under $50. Okay, so that means that HI would be mu is less than 50. Doesn't equal $50, it's not greater than. So because it says under then, it has to go into HI. It can't go into HO. Why can't it go in HO? Because HO always requires an equal sign. So in this case, mu would be greater than or equal to 50. Okay, so there's your HO and HI. Now, the other thing, some of you are having some serious difficulty finding your critical values, or at least telling me what your critical values are. I understand that you can't draw a picture like I can necessarily, or if you do draw a picture, one of you has taken to just sending me copies of your work upside down, but that's okay. Believe it or not, I can actually read upside down. So, again, make sure you identify your claim as with a little star. Now, for this one, since the claim is less than, then it's a left-tailed test, and you're going to fill in over here. We said that alpha was equal to 0.01. So, what does that mean? Well, since this is a z-test, and it's 0.01, and it's one tail, we just go all the way down to our wonderful little friend at the bottom. Now, this is on the left-hand side, so instead of 2.326, we would do negative 2.326. Now, if you're not using the t-table and using infinite degrees of freedom, you're going to get negative 2.33, which is still fine. I'm not going to mark off for that. But some of you are coming up with really weird numbers here. Now, guys, this is not a t-score, this is a z-score. So our formula for this, and I'm really getting, some of you are really confused about what was observed and what was expected. Guys, anything that they give you that says, this is what you saw, that's observed. So this should be 5325. Minus 50 all over 7.15 over the square root of 35. So that gives us a 2.69. clearly this 2.69 is way over here, so it's not in the critical area. So what do? We fail to reject the null. And guys, you have to write this. You can't just go right into the conclusion. You have to write fail to reject null. Okay, and then you go into your conclusion. Therefore, we do not have enough evidence at alpha equals 0.01 to what? Support the hoe? No. Reject the hoe, support the high. Those are the only two words you should be using here. Please do not use the word accept. One of you is using accept an awful lot, and that's not what we're looking for. It is either support if it's HI or reject if our claim was HO. So the HI was our claim, so we do not have enough evidence to support. Dinner's costing less than $50. Okay. So what is that saying? What that really is saying is we think that the restaurant is full of it. We don't believe them. We say that we're going to say that that's not. We would say, excuse me, I think that you're falsely advertising. Okay? So again, if you use the correct verbiage in your conclusion, things make a lot more sense. All right? Some of you are still trying to use, do a little shortcut for some reason. I don't understand why. Okay. The second of 9. A report claims changing your oil every 3,000 miles instead of 5,000 will not affect your yearly maintenance costs. You tested this by polling 20 random people who changed their oil every 3,000 miles and found the mean yearly cost to be $235. So guys, just to write this stuff down, N is 20. X bar, their cost is $235. Mu is 214. It says the national average is 214 with a standard deviation of $31. And again, this was a sigma. National average, national sigma of $31. What is your conclusion at alpha equals 0.05? Okay, so what is HO? According to the problem, it says a report claims changing your oil every 3,000 miles will not affect your yearly maintenance costs. Okay, so we are looking, and remember the yearly maintenance cost is 214. That's the national average. So we're going to say for HO, mu equals 214. Some of you are getting the which mu you're supposed to be doing. Okay, and then HI is not equal to 214. Again, this is a z-score, so you can use your t-table with all the way down at the bottom with the infinite degrees of freedom. We have alpha of 0.05, so that should give us, and remember it's two-tailed, so we have to account for that. So that gives us 1.96, both plus and minus. Okay, so our z-score is going to be the observed minus the expected, so it's 235 minus 214 all over 31 divided by the square root of 20. Okay, so that gives us the z-score of 3.03. Now that is clearly way past the 1.96. So once again, because we're in the critical range, we are going to reject the null. And by the way, which one of these was your claim? Well, it says it claims it's not going to affect it, so that means that there's no change. All right, so therefore, we have enough evidence at alpha equals 0.05 to, again, one of two words, support or reject. The claim is HO, so this time we're going to reject the claim that changing oil every 3,000 miles does not affect yearly maintenance costs. Because clearly it does affect it. Okay, so there's double negatives and all that fun stuff, so just make sure that you're paying attention to what's happening here. Okay, you guys are smart, you guys can do this, you just need to be really, really careful. And again, I was intentionally gave you two z problems because I wanted to see if you would pick up on the fact that they were z problems. And I think only one of you did. Maybe two. But anyway. All right, so then number 3 was the speeding ticket problem. Okay? So you have to tell your parents about the speeding ticket. So let's read this one. You plan to claim it can't be more than $150. Okay? So after checking with 12 random people, n equals 12, you find the mean is, so x bar equals 156. S, because this is the one that you did, this is not a national average or anything like this, so the standard deviation is $5. Alpha equals 0.01. What's HO? What's HI? Okay, it's what you're talking about. You claim it can't be more than $150. Okay, so if it can't be more than $150, that means that you're going to say that mu is less than or equal to $150. Remember, more than includes equal to. And then that means HI would be mu is greater than 150. Which of these is the claim? You said it can't be more than 150, so there you go. All right, so let's work this problem out. Again, this is a t-score. Okay, so this time we have to actually use our t-table, and we have degrees of freedom equal to 11. Okay, alpha was 0.01, and this is a one-tailed test. Now remember, HI always tells you. Okay, so this is a right-tailed test. All right, so alpha equals 0.01, so we just go down the 0.01 column to 11 degrees of freedom. And let's see. No, alpha is 0.1, not 0.01. Is that the problem? Oh, there we go. I typed that in wrong. Okay. So alpha equals 0.01. So you should get a 2.718. Okay, so now we use our t-score. Well, again, the t and the z are exactly the same except for the which letter's out front. Other than, of course, the sigma makes the difference. So you have x bar, which is 156, minus 150, all over 5 divided by the square root of 12. So that equals 4.157. So that's up there, right? That's up there and out there. So what are we going to do? We're going to reject the null. Have to write that. Then you can write your conclusion. Therefore, we have enough evidence at alpha equals 0.01 to reject that the ticket will cost no more than 150. Okay. Onward and upward. Again, once you get the hang of this, and I'm seeing it between 8.3 and 8.4, the problems I'm seeing, some of you getting a little bit more hang of it, and some of you are still a little bit backwards. Just take your time, make sure you understand what goes where, and this is easy because it's the same thing over and over, right? Okay, and don't forget, all these need conditions, but like I said at the beginning, you guys are listening to me. You're doing a good job with your conditions, so I'm not too worried about that. The next one was the average person driving 9 miles per hour over the speed limit. Okay. You clock 35 random teenagers, n equals 35, and find that they average 12 miles an hour with a 3 mile per hour standard deviation. So x bar equals 12. According to this, mu equals 9, and s would be 3. And again, we want alpha equal to 0.01. Okay. What's our null hypothesis? Okay. What are we saying? What are we thinking? Okay. The null hypothesis says that the average person is 9 miles per hour. So mu equals 9. And remember, what did the question say? It says, test to see if students are different. Okay, so different means that I'm looking for either greater than or less than. So in other words, I'm looking for mu not equal to 9. Okay? What's my claim? Well, my claim is going to be that it is different. Okay? So, what do we need? This is now a two-tailed test, ladies and gentlemen. It's still a t-test because we have a standard deviation that comes from a sample. So our degrees of freedom here is just simply 8. But remember, since this is two-tailed, we have to take that 0.01 and divide it in half. So we're going to move over one extra column to 0.005. We're going to go down to 8. And we're going to get 3. No, why did I say 8? Wow, I'm losing it. N is 35, guys. 35 is not on here, so we're going to use 30. Okay, we're still going to go over to 0.005. So we're going to get 2.750 plus or minus 2.750. Remember, it's two-tailed. 2.750 negative 2.750. Okay, again, n was 30. Our degrees of freedom that we're going to use is, n was 35, degrees of freedom that we're going to use equals 30. You go down. You can't have more degrees of freedom, but you can go down. And we've talked about that. We even talked about that when I actually last saw you. Okay, so let's use our t. Let's find our t-score. T equals observed minus expected, so 12 minus 9, over 3 divided by the square root of 35, which gives me a t-score of 5.92. And again, we are going to reject the null. Therefore, we have enough evidence at alpha equals 0.01 to support teens drive differently. Now, this isn't saying that every teen drives differently or anything like that. It's just saying that teens drive differently than the adults. And I think we all know that that's pretty much true. Okay, so the last question that we had in section 8.3 was your first apartment. Okay. You're looking for your first apartment and you think that they average $850 per month. Okay. So mu, we say, is 850. After 33 random places, so n equals 33, your mean, x bar, was 974, with a standard deviation of 296, so s equals 296. You may have to rethink your plan. Alpha equals 0.05. What is HO? What is HI? You think they average 850. Okay, so what are we looking at? We're looking at mu equals 850. Okay, so HI would be mu not equal to 850. And of course your claim is what you think it is. So your claim in this case is HO. Okay, where do we go from here? Critical values. This is going to be a two-tailed test again. Why? Because we have not equal. So we'll fill this in. N is 33, so once again, we have a degrees of freedom that we're going to have to use of 30. Remember, alpha was 0.05, so we're going to have to divide that by 2. So 0.05 is divided by 2 is 0.025. We go down to 30 degrees of freedom, and we should get, if I see my chart correctly, plus or minus 2.042. So I have negative 2.042 and positive 2.042. Now we've got to get our t-score. So it's 974. That's the observed minus what you thought the expected was 850. Divided by 296 over the square root of 33. And that gives us 2.407. Well, that's actually relatively close, but what do we still do? We still reject the null. And again, you must write this. Therefore, We have enough evidence at alpha equals 0.05 to reject that apartments cost $850 per month. So clearly we do need to rethink our plan. Now, let's move into our proportions section. These are the things I assigned on Monday that were due to last night at midnight, and I checked through them this morning before I did this video because I wanted to see what you all needed. Again, good job on the conditions. These are the ones that the check for normality is different. Okay, you actually have to multiply because it is a proportion. So you need to make sure that you understand that. Now, some of you are having some real difficulty with what's what in here. So let's go ahead and go through these 4 problems I gave you. Mr. Kronk estimates that 30% of seniors do not take 8 classes. Okay, so that means that P equals 0.3. Means Q equals 0.7. Okay. To test this, he pulled 50 random seniors, so N equals 50, and found only 18% not taking 8 classes. So P hat equals 0.18. Okay. Test Mr. Kronk's claim at alpha equals 0.05. All right, what is HO? What are we thinking? HO, P is equal to 0.03. No, yeah, not 0.03. 0.3. HI would say that P is not equal to 0.3. Okay, and what's the claim? 30%? Okay, right there. Now, remember, with proportions, it's just like a z, so you can use those infinite things. Alpha equals 0.05, cut it in half because it's two-tailed, so 0.025. Infinite, so negative 1.96. Positive 1.96. Okay. Again, with proportions, it is a z-score, and you just have to remember it's P hat minus P over the square root of P times N over, P times Q divided by N. So I get P hat minus P, so it's 0.18 minus 0.3 over 0.3 times 0.7 divided by 50. And that gives me negative 1.85. So ladies and gentlemen, negative 1.85 is not in my critical area. So that means that I fail to reject the null. Therefore, we do not have enough evidence at alpha equal 0.05 to what? To reject. Remember, only 2 words go here, reject or support. that 30% of seniors don't take 8 classes. Okay. Second proportion problem. The second proportion problem was the students thinking that 80% of all adults have gotten a speeding ticket. All right. So a student claims over 80% of all adults have gotten a speeding ticket. So P is going to be 0.8. Q is going to be 0.2. P hat is going to be 172 out of 200, and N is going to be 200. You'll see where I got that in a second. You test this by sampling 200 random adults. 172 said they had received a ticket, and we have alpha equals 0.05. What was my conclusion? Well, first off, HO says that P is going to be what? How am I going to do this? It says, I think that over 80% of all adults. Okay, so I'm going to, since over 80% indicates that I cannot have the equal sign, then that's got to be my HI. So P is greater than 0.8, which means that P is less than or equal to 0.8 would be HO. And again, HI in this wonderful case is my claim. Critical values, z-table, right tail. Okay. So we have alpha 0.05, so that should give me 1.645. Now, what is my z-score? Because remember, proportions are z-scores. I take P hat minus P. Well, P hat is 172 over 200. If you're careful, you understand that that is 0.86 minus 0.8 divided by the square root of 0.8 times 0.2 over 200. And if you're very careful there, you get 2.12. A lot of you are having some difficulty and you're getting really, really small numbers. This whole thing is in the radical, guys. So you do your 0.8 times 0.2 and then divide by 200 and then take the square root. Others of you are getting the wrong sign. That's just because you don't know the difference between P hat and P. Okay. So 2.12, that is clearly in the critical area, so we're going to reject the null. Therefore, we have enough evidence at alpha equals 0.05 to support over 80% of adults have gotten a speeding ticket. By the way, I would not be in that part because I, knock on wood, whatever, have never gotten a speeding ticket. And typically the way that I drive, I probably won't, but okay. All right. Now watch, I'll give it a speeding ticket like tomorrow. Anyway, Next part. Next question. Question number 8 out of 9 was, you think at least half of all teachers got referrals when they were in school. A random sample of 20 teachers found that 27 of them had referrals. You test your claim at alpha equals 0.1. All right. At least half. Okay, so that means that P is greater than or equal to 0.5. Okay. So that right there tells you what your HO is. HI would indicate that P is less than 0.5. And of course, HO is now your claim, because that's what you said it was. Right, so let's find our critical value. That's my dog waking up from a nap. Alpha was equal to 0.1. So, if alpha is 0.1, HI indicates that we're looking at a left-tailed test. Okay, so at 0.1, not 1.1, we have negative 1.282 as our critical value. Okay, so our z-score is going to be P hat, which was 7 out of 20, minus 0.5 over the square root of 0.5 times 0.5 over 20. And that gives us negative 1.34. So what are we going to do? This time we are going to reject the null. Therefore, we have enough evidence at alpha equals 0.1 to reject the claim of at least 50% of teachers got a referral in high school or in school. Easy enough? Hope so. Got one more to do, and then I can upload this video and you all can watch it, and you can watch that in the senior awards, and that'll take about 2.5 hours of your day. Anyway, last problem. You read that over 75% of all college professors are Democrats. To test this, you sampled 250 random professors and found that 208 are Democrats. All right, so P is 0.75. Q is 0.25. P hat is 208 out of 250. N was 250. And it says use a 95% confidence level, so alpha equals 0.05. All right, so what's HO? Read the problem carefully. You read that over 75% of all college professors are Democrats. Okay, so that means if I'm just dealing with over, that does not include equals, so that means that P greater than 0.75 is my HI. Because remember, HO has to have equals in it. So in this case, P would be less than or equal to 0.75 for HO, and my claim is going to be HI. So what do I do now? Critical value. I hear you. Critical value, it's going to be right-tailed. Fill that in. We have, hello Eleanor. We have a alpha of 0.05 because that's 95%, which gives us 1.645 as my critical value. All right, now we got to do our z-score. Z is going to be 208 over 250 minus the 0.75 divided by the square root of 0.75 times 0.25 all over 250. So that gives us a z-score of 2.99. And clearly that is well into the critical range for 95% confidence. So we are going to reject it. Therefore, we have enough evidence at alpha equals 0.05 to support that college professors are Democrats. All right, done and dusted. Again, all 9 of these problems need your conditions. You guys did a great job with that. Not too worried about that. So I will be checking on what you've turned in for me that's due at midnight tonight. This is not due until, you don't have to watch this, or it doesn't have to be completely watched until Thursday. So there's one more assignment, guys. Well, 2, sorry. And that'll be it. So I know this is a long one, and thank you for your time.